A very good morning, children. So, we have started learning our chapter number 3 from Science 1, that is current electricity. In our previous lecture, we have learned the concept of resistors in series. So, when the resistors are said to be in series, as when they are connected in one line, then those resistors are said to be connected in series. Now, we are going to solve numericals based on resistors in series. Solve examples for resistors in series. Example 1. Three resistors having resistances of 15 ohm, 3 ohm and 4 ohm are connected in series. What is the effective resistance in the circuit? So, first we have to write the given things, that is R1 is equals to 15 ohm, R2 is given as 3 ohms, R3 is equals to 4 ohms. So, effective resistance Rs is equals to R1 plus R2 plus R3 will give you as 15 plus 3 plus 4. So, answer comes as 22 ohms. So, therefore, the effective resistance in the circuit is equals to 22 ohms. Example 2. Two resistors having resistances of 16 ohm and 14 ohm are connected in series. If a potential difference of 18 volt is applied across them, calculate the current flowing through the circuit and the potential difference across each individual resistor. Here we have to calculate the current and the potential difference across the resistances. So, given R1 is 16 ohms and R2 is 14 ohms. Rs is equals to 14 ohm plus 16 ohm. So, which will give you the answer as 30 ohm. Now, let the current flowing through the circuit be I and the potential differences across 16 ohm and 14 ohm be V1 and V2 respectively. So, current is I and the potential difference V1 and V2. So, V is equals to IR. So, V is equals to V1 plus V2. So, answer is 18 volt, which is given in the numericals question. That is, if a potential difference of 18 volt is applied. So, I is equals to V upon R. So, 18 volt upon 30 ohms. Our resistance we calculated first came as 30 ohms. So, therefore, I is equals to 0.6 ampere. When we divide 18 volts by 30 ohms, answer comes as 0.6 ampere. So, V1 is equals to I multiplied by R1, which will give you as 0.6 multiplied by 16. And that answer when multiply comes as 9.6 volts. So, V2 is equals to IR2, that is 0.6 multiplied by 14, which will give you as 8.4 volt. The current flowing in the circuit is 0.6 ampere and the potential differences across the resistance 16 ohm and 14 ohm are 9.6 volt and 8.4 volt. Let's revise example number 2 once again. First of all, what is the question? Pay attention. Two resistors having resistances of 16 ohm and 14 ohm are connected in series. If a potential difference of 18 volt is applied across them, so the potential difference applied between the two resistors which are connected in series is 18 volts. So, we have to calculate the current flowing through the circuit and the potential difference across each individual resistor. So, first we have to calculate the current which is flowing through the entire circuit, and then we have to calculate the potential difference across each individual resistor. So, first we have to write all the given thing. R1 is given as 16 ohm, which is the first resistors which is connected in series, and R2 is equals to 14 ohm. Now, Rs, that is resistors in series, is equals to 14 ohm plus 16 ohm. which will give you as 30 ohm. When you will add 14 plus 16, you will get the answer as 30 ohm. So Rs is equals to 30 ohm. Now let the current flowing through the circuit be I. Here students, we have to find out the current that is flowing through the circuit. So let us assume that let the current flowing through the circuit be I and the potential differences across 16 ohm and 15 ohm be V1 and V2 respectively. Now V is equals to IR. V stands for potential difference, I is the current and R is the resistance. So we know when we have to find out the potential difference, the formula is V is equals to I multiplied by R. And in the question, V is equals to V1 plus V2 is given as 18 volts. So I is equals to V upon R, where we have to find out the current, and V is given as 18 volt and R we calculated as 30 ohms. So when you divide 18 by 30, you get the answer as 0.6. So I is equals to 0.6 ampere. Now V1 is equals to I multiplied by R1, that is I is equals to 0.6 and the resistance, first resistance which was connected in series was 16 ohms. Now 0.6 multiplied by 16 will give you the answer as 9.6 volts, because the unit for potential difference is volt. V2 is equals to I multiplied by R2. So I is equals to current, which is 0.6 multiplied by 14, which is equals to 8.4 volt. So therefore, the current flowing in the circuit is 0.6 ampere and the potential differences across the resistances 16 ohm and 14 ohm are 9.6 volt and 8.4 volt respectively. So students, in this numericals, two resistance was connected in series and the potential difference of those two resistance applied was given as 18 volt. We have to calculate the current which is flowing through the circuit, and then we calculated the potential difference across each individual resistor, across the resistor of 16 ohm and across the resistor of 14 ohms. Now moving to the next concept, that is resistors in parallel. Resistors are said to be connected in parallel when their ends are connected at both sides as shown in the figure. The figure shows three resistors R1, R2 and R3 connected in parallel between points C and D. V is the potential difference between C and D. Let I1, I2 and I3 be the currents flowing through R1, R2 and R3 respectively. Then the total current flowing through the circuit is I is equals to I1 plus I2 plus I3, which is the equation 1. Let Rp, P stands for parallel, be the effective resistance between C and D. According to Ohm's law, I is equals to V upon Rp. Similarly, I1 is equals to V upon R1. I2 is equals to V upon R2. I3 is equals to V upon R3. Substituting these in equation 1, we will get as V upon Rp is equals to V upon R1 plus V upon R2 plus V upon R3. Therefore, 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If n resistors are connected in parallels, then 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And till the 1 upon Rn if n resistors are connected in parallel, that is the number of resistance are connected in parallels. Now let's solve examples of resistors in parallel. So example number 1. Resistors having resistances of 15 ohm, 20 ohm and 10 ohm are connected in parallel. What is the effective resistance in the circuit? So we have to calculate the value of effective resistance in the circuit where the resistors having resistances are given. So first write the given things. Given R1 is equals to 15 ohm, R2 is equals to 20 ohm and R3 is equals to 10 ohm. So what's the formula? What's the concept to find out resistors in parallel? So 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we don't know the value of 1 upon Rp, which is equals to 1 upon R1 is given as 15. So 1 upon 15 plus 1 upon 20 plus 1 upon 10. We have substituted the values. Now 1 upon Rp is equals to, now students, we have to make the denominator as the same. So the largest number here can be come as 60. So we can multiply 15 by 4, it will come as 60. 20 by 3 will get the answer as 60 and 10 multiplied by 6 as 60. So as we multiply in the denominator, we also have to multiply same number in the numerator. So when we do the multiplication, the final answer comes as 4 plus 3 plus 6 upon 60. We have written the denominator as once only because it is common in all the three. So write it once. So when we add 4 plus 3 plus 6, it gives you the answer as 13 upon 60. Now we have to find out the effective resistance in the circuit. So take the reciprocal of 13 upon 60. After taking the reciprocal, answer comes as 60 upon 13, that is Rp upon 1. First it was 1 upon Rp. We have to take the reciprocal because we have to find out only the effective resistance in the circuit. That's why we took the reciprocal, and taking the reciprocal means shifting the numbers into numerator and denominators, exchanging the numbers of numerators and denominators. So Rp is equals to 60 upon 13. Now when we divide 60 by 13, 13 ones are 13, 13 fours are 52, 8 remains, then 13 six are 78, then 2 remains, already decimal point is there, add a 0, then 2, it comes as 20. So 13 ones are 13, 7 remains and 13 fives are 65. So this division will be carry on further, but our final answer we calculated as 4.615 ohm. So therefore Rp is equals to 4.615 ohm. Effective resistance in the circuit is equals to 4.615 ohm, less than the least of the three 10 ohms. Now moving to the next solve example, that is example 2. Three resistors having resistances of 5 ohm, 10 ohm and 30 ohm are connected in parallel, and a potential difference of 12 volt is applied across them. Obtain the current flowing through the circuit and through individual resistors. What is the effective resistance in the circuit? Here the three resistors are connected in parallel and the potential difference applied across them is 12 volt. We have to find out the current flowing through the circuit and through individual resistors. What is the effective resistance in the circuit? Now given, what are the given values? R1 is equals to 5 ohm, R2 is equals to 10 ohms and R3 is equals to 30 ohms, and V, that is the potential difference, is given as 12 volts. What's the formula to find out the current? I is equals to V upon R. So I1 is equals to V upon R1, which is equals to 12 divided by 5. So when we divide 12 by 5, the answer comes as 2.4 and it is 2.4 ampere because current, the unit of current is ampere. I2 is equals to V upon R2, where V is given as 12, R2 is the resistance of the resistor, which is 10 ohm. So 12 divided by 10, it will give you the answer as 1.2 ampere, and I3 is equals to V upon R3, which is 12 upon 30, which will give you the answer as 0.4 ampere. Now I is equals to I1 plus I2 plus I3. So, we have calculated the value of I1, I2 and I3. Now, substitute the values. 2.4 plus 1.2 plus 0.4. While adding all the three, you will get the answer as 4.0 ampere. Now, we have to also find out the resistors, the resistance in the individual resistors. So, as we know, they are connected in parallel. So, what's the formula? 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. R1, R2 and R3 is the given values. So, 1 upon 5 plus 1 upon 10 plus 1 upon 30. Now, again here we have to make the denominator same. So, the end, that is 1 upon 30 is the largest denominator. So, can we make the R1 and R2 as 30? Yes. So, if we multiply it by 5 by 6, you will get the answer as 30, and if we multiply 10, that is the second resistor, by multiplied by 3, we will get as 30. So, as we multiply in the denominator, we have to multiply with the same number in the numerator. So, 1 multiplied by 6 upon 5 multiplied by 6 plus 1 multiplied by 3 upon 10 multiplied by 3 plus 1 upon 30. So, it will give you as 6 upon 30 plus 3 upon 30 plus 1 upon 30. Then, denominator is the same, write it 1. 6 plus 3 plus 1 upon 30. So, by adding, you will get the answer as 10 upon 30. Now, 10 ones are 10, 10 threes are 30. So, we get the answer as 1 upon 3. So, effective resistance in the circuit is equals to 3 ohms, and the current flowing through the resistances 5 ohm, 10 ohm and 30 ohm is 2.4 ampere, 1.2 ampere and 0.4 ampere respectively. The total current flowing through the circuit is 4 ampere. Students, you can refer to this numericals on your textbook page number 42. Here you in the video, here you only go through the mathematical calculations. Otherwise, the entire numerical is solved in the textbook, which you will get on textbook page number 42. So students, we have completed our lesson number 3, current electricity. Today, what all concepts we learned? First, we solved the numericals based on resistors connected in series. Then we learned the concept of resistors in parallel. Then we had solved the examples of resistors in parallel. To get your concept more clear, watch the video attentively. Thank you so much students for your attention. Watch all the videos of this chapter. Thank you. Goodbye. Have a nice day.